Hello, welcome back. Today we'll be going over inheritance as a concept in object-oriented programming. In our last video, we went and expanded on what we learned from the first video. That being, how do we create initialization functions, how do we create dunder methods, what are dunder methods, what are getters, what are setters, what are attributes, being members, what are methods, being any function that appears within a class. Right. For today's video, we will exit our intro0.py file and create a new file. Let's call it intro1.py. Let's just create a simple class. We want to model behaviors of a person. So let's create a class and we'll just call it person. Now remember, there is no need for us to pass in the object parameter because inherently Python knows that our class object will inherit from the object, so no need for us to do that. We want some things to happen once we initialize a person object. So we create an initialization method, which is also called a dunder method, and we must pass in self. Now, what are parameters that we wish for every person object to have? Let's keep it simple. Let's just say a person has a name and an age. Then we can say that self, which refers to the current calling object, dot name is equal to name, and self dot age is equal to age. And let us also create a very simple function. Remember, a function that appears within a class definition is called a method. Let's call it something like introduce, which will take in parameter self. And the only thing it will do is print. Actually, let's do a return, which will be an f string. Hello, my name is, and we will pass in the parameter name. Should be self.name because it's current calling object, self.name. And I am self.age years old. All right, simple. So now when we create a person object, let's say person1 is equal to person, and we pass in a name. Let's go with Azura with the age of 7. Now when we do something like print person1 dot introduce, if we save this file and run it, we get the output, hello, my name is Azura and I am 7 years old. And we're going to do it one more time. Let's create another person, person2, person, and we pass in some name. Let's go with George. And let's say George is 21 years old. And if I print person2 dot introduce, save my file and run it, I get hello, my name is Azura and I'm 7 years old. And I get hello, my name is George and I am 21 years old. Now, let's create another class. Let's get rid of this. Let's say I want to create a class instead of a person. I want to create a class for a subset of person, that being a man. And I want some attributes to be true for every man object I create. So I'll create my initialization function. And I want a man to have a name and an age. I want to set the man's self.name equal to name and self.age equal to age. Self.age equal to age. Something wrong here. Oh, there we go. Right. I'm also going to create an introduce function just so that we can introduce our person. Well, our man in this case, introduce. And it will take the parameter self. It will be similar to this function, so let's copy it. We'll do a return. And we will also just add to that, I am a man. Let's create a third class, and this time I want to model a woman. And I'll keep it very simple. I'll just copy my man class and I'll create a woman class. Only thing here I have to change is instead of I am a man, I am a woman. Now, if we create some object, let's say man is equal to man. Let's give a name, Ash, and let's give Ash Ketchum from Pokemon and give an age, let's say 10. Let's create a woman and say woman. Let's go with Joy, as in Nurse Joy, and let's go with 30. I obviously must make sure this class is called woman. And then I will go print man.introduce, and I'll do print woman.introduce. I will save everything and I will run my file. And I get the output, my name is Ash, and I am 10 years old, I am a man. Hello, my name is Joy, I am 30 years old, and I am a woman. Now notice something. We have some class above here, the person class. It has some built-in, it has some functions that we built. The initialization function and the introduce function. The initialization function sets attributes. The introduce function just returns some output. And if you look at the man class, it may not be the person class, but it is very similar. We have the same number of attributes, and we are doing the same thing. We are saying start.name is equal to name and start.age is equal to age, which is the same thing we're doing for the woman class. In fact, the introduce function up here is also very similar to the introduce function in our man class and our woman class. Let's go one step further. We know that every person is either a man or a woman, or a subset, that being a young man, young woman. So would it make sense for us to somehow use the person class as some, let me just add, use the person class as some base class which has some base attributes. Remember, an attribute is also called a member, which is also a variable linked to your instance of the class. So our person class has some attributes and has some methods. Methods are functions that appear within a class. So how can we use that in other classes? This is how we do it. We say because we have another class man, and because it essentially behaves very similarly, or it inherits values from a higher class, in this case the person class, we can actually use it. All we do is we open parentheses and we pass in the person class. What this says is when we create our class called man, we want it to inherit stuff from our base class. How do we do that? Well, instead of doing the self.name is equal to name and self.age is equal to age, all I have to do is say super dot and then call the function. In this case, I want the initialization function, name, age. What this does is we have our initialization function. Within that function, instead of setting values ourselves, what we say is super. What super does is it calls the parent function that will be provided. So in this case, it's super. Because we pass it in init, it goes, looks in the person class, it finds the initialization function, and then it runs it. And the reason we pass in two parameters, name and age, to our initialization function is because we need name and age in our initialization function. We can take it one step further. Let me go remove that. I'll actually change this for now from return to a print. And great. And in the introduce again, instead of writing the introduce function myself, all I will do is super again, and I will call the parent function that I want, in this case introduce. And this should, all The only thing this should do is print hello, my name is name, and I am 8 years old. And then we will add some added functionality by adding print I am a man. Now we can copy this and we can do the same thing for our woman class, because again, a woman is just a subset of man. I mean, a woman is just a subset of person, and instead of saying I am a man, I am a woman. Great. So now when we print exactly one argument, it takes exactly one argument, the instance to initialize. Seems like I made some mistake here. Let me just try to run through things in my head. Right, introduce. Let me look at that error again. Oh, so it takes one argument, the instance to initialize, and I am passing 2, which is being called here. Okay, so let me just get rid of that for now and see. Oh, okay, that's the problem. So for some reason, the woman class is acting different, even though it takes in a variable name and age. It sets that name to name and it sets that age to age. Super.init name age, right? Name age. Oh, I see the issue. Notice that in our woman class, I'm calling the super function. The super function looks into the parent class for the following function, but I didn't provide the parent class. So all I have to do here is pass in person. And then when I create a woman object, in this case woman, which is equal to woman, given some name, let's go with Joy, 30 years old. And now when I do print woman dot introduce, I will get the required output. There we go. Let me just clear everything up. I will actually, instead of doing print, I will do return. That should make things a little better. Return. Hey, there we go. Hello, my name is Ash and I'm 10 years old. I am a man. Hello, my name is Joy and I am 30 years old. I am a woman. And that is the concept of inheritance, which is quite simple. We have some base class with attributes and methods that we want to be established in lower classes, which are called child classes. So in that case, we use the concept of inheritance. How do we go through inheritance? So typically, we can do a top-down approach, where we find some base class such as person, and then we realize that a class such as man and woman are basically people, and therefore they should inherit from the person class. Or we can do it the other way. Let's for fun say we first wrote the woman class, then we wrote the man class, and we noticed that they shared a lot of behavior amongst them. Well, in that case, we can look ahead and say, well, man and woman are both person, let us create a person class. And that's it. Quite simple.